Hi, welcome to 7.7. These are Polygon Constructions. So first I want to review the constructions we've already done in previous sections in the book. We have our first construction we learned was how to make a circle in 1.7. The second one, we copied a segment and we also bisect a segment. We know how to do both of those constructions from 3.6. We know how to bisect an angle and copy an angle from 4.6. And we know how to make a perpendicular through a point from 5.7. Now in your book on page 298, it says a review of construction 3. That is false. It's construction 6. So perpendicular through a point is what I want to concentrate on. I want to just kind of have a refresher on how to do this particular construction because it's similar to some other things that we're going to do in the other constructions. So let's go ahead and get started with how to do that. If you remember, we need to make a radius that will go through the line in two places. So it's got to be further away than directly below. So I've got a new point here and I've got a new point here, right? Okay, so now I can now measure from here to here, and I'm going to make an eyebrow there, and I'm going to make sure my compass didn't move any. That distance is the same. And I have a new point that I can now connect with my straight edge from here to here. And this actually proves how you need to have very sharp pencils because my compass is very dull and I can't seem to figure out how to get it sharper. So unfortunately I'm stuck. As given a segment length, we can make this a bisector. This is actually just a perpendicular through a point, and it's not officially a bisector because it's a line going infinitely in both directions. So if I needed to prove this, yes, the magic word that everyone loves to hear, I need to prove this. The given would be that I have a line, and I would just call this line AB and this point X. So given line AB contains a point, contains a point, which is going to be this point right here. And I'm going to say that this is point P. Your book is always calling that extra point P. That's going to be my given, okay, that the line contains a point. Then from PA to PB is congruent. And the reason why I know from here to here is congruent from here to here, this is point B right here. There. Does that make, hopefully that makes better sense. Your book actually draws little dash lines. Okay, so that point, that distance from P to B and from P to A is congruent, and the distance from A to X is congruent to X to B. And the reason for that is because that would be a congruent circle. That's a radius right there. That's a radius of a circle. I just happen to only draw two eyebrows, two chords, if you will, of that circle. Okay. Then I have to say that PX is congruent to PX. So here to here is congruent. And if I have three sides and they're all congruent, I have congruent triangles by side, side, side. And then once I have congruent triangles, I can prove that angles are congruent to each other, right? I can conclude that this angle is congruent to this angle because of definition of congruent triangles. I can also say that these two angles form a linear pair, right, by definition of linear pair. And I can also say that this is now a right angle because if congruent angles form a linear pair, then they are right angles. That was a theorem we have not used very much. And then therefore I can say these two lines are perpendicular by definition of perpendicular. Okay, so that proof is in your book, but I just wanted to review that with you. So let's go ahead and continue on. Now, the other construction we did in 5.7 was a 45-degree angle, and we also did an equilateral triangle, which, if you remember, if you only do half that triangle, you have a 60-degree angle, because equilateral triangles have 3 60-degree angles. So 6, 7, and 8 were all in 5.7. So construction 9 is your first construction in this section. So all of that was review. Okay, so hopefully we're all good to go now. We are going to copy a triangle. The first thing we have to do is we have to copy the segment, which was the second construction we learned, and you're going to start with a line segment right here, because we have no idea how long this line is going to be. This segment is going to be this part of this triangle. So first thing I need to do is measure it with my compass. I'm going to make a point on this line so I have a starting place. Okay, so a little bit bigger. Looks pretty good. Okay, so I now have the base of my triangle. Okay, this is where we're going to forget that this is graph paper, because it's too easy to get caught up with the grid here. I should have done this on blank paper for you. But we're going to measure this side, and all we're going to do is make an eyebrow. Somewhere where we think that point might intersect this other line. I happen to make a right triangle, but it doesn't matter if it's a right triangle, scalene, acute, obtuse, isosceles, does not matter what kind of triangle we have. Okay, so now I'm measuring the long side here. Go to this pivot. Now this point of intersection is going to connect to my bottom point and to my starting point. And I just copied a triangle. Okay, our next construction is to copy a polygon. So the easiest way, I made kind of a crazy polygon. It doesn't matter how many sides it has. It could be 4, 5, 6, 7, 8. Okay, especially if it's irregular like this one, we need to try to divide this up into triangles, because we know how to copy a triangle. So I'm going to make some light marks here and connect some corners and vertices. So I don't know if you can tell, but I have 3 triangles now. Okay, this gets a little hard to make it exact, so please don't be frustrated if you try this and it just looks a mess the first try. So if you fail, try again, because this is probably the hardest construction you're going to do in the entire class. So first thing, copy the bottom segment. Now I'm going to go for this point here to be over here somewhere. I'm going to copy this little triangle. And my dehumidifier is so loud when it shuts off, it feels very quiet. It's a much more obtuse triangle than I originally did. Ooh, I almost missed again, but I got it. Right here. Okay, so I'm just going to draw the one side that I need. I'm not going to draw the whole triangle. Okay, now I'm going to make this point. And you just work yourself. Now I'm working like on a second triangle here. Okay, so hopefully you're able to tell what the heck I'm doing, because this is hard to explain as I go, but if you can imagine with me here that I've done this triangle and now I've done that triangle. Okay, so now I just have one more point. I need this vertices out here. It's kind of far out there here. And then I need to measure the third side of the triangle. Right there. And then I can connect my last point here, and hopefully it resembles that original thing there. Okay? So, copy to polygon. Basically, all you're doing is copying a triangle multiple times. That's, if you know number 9, you can figure out number 10. Okay, so the last but not least is our construction of 11, and that is called parallel through a point. Okay, this one we're going to use our parallel postulate to make this work. So first, right off the bat, we are just going to draw a transversal. Okay, we're going to draw a line that goes through point A and intersects our line. Okay, and I'm going to make it at an angle so it's definitely not a perpendicular. Okay, so this is our point A, if you will, right here. Okay, and so now I have a new point. We're going to call that point B right there. So I just drew a transversal. Now my goal is to make a parallel, because this is my line K, and I want to make a line L up here somewhere that is perfectly parallel. So I need to make some angles, and they need to be exactly the same measure. So I'm going to use my compass because I can't use my protractor to measure. Now I'm going to go ahead and do alternate interior angles just because they're fun, but you can do corresponding as well. So this is the radius of that angle I'm going to make, and I'm going to do it right from point A as well. Maybe I am. I'm going to turn my paper because my compass has a fat lead here. Oh, I did corresponding. I already lied to you there. So I did corresponding angles, but you could also do alternate interior. You could have done an angle this way, right? If you imagine that there's going to be a parallel line here, we could have done an angle here to do alternate interior. I did corresponding after I said it, so it's stuck in my head. Alright, now I have to measure the distance between these 2 points, because remember, I'm copying an angle is what I'm doing, and we already know how to copy an angle. So I still need a little bit shorter here. There we go. So here's my line of my transversal. Now I have a point. I have 2 points to make a line. So here's my 1 point. Oh, that didn't work out too well for me, but we're gonna see if we can make it look nice here. It's not exactly parallel, but it's mostly because my compass is not sharp. So if I could fix that, I will. But anyway, that's how you do it with corresponding. Now, if I did it with alternate interior, I would have made this eyebrow, I would have made it here, and I would have measured from here to here, and this would have been my hash mark. My point would have just been on this side of point A. Alright, so that's it. Those are the 3 constructions. Now, for your whisk summary, I want you to look up the word triangulation. I want you to tell me, its definition. So define, and when is it used? Okay, so this is for your whisk. Define triangulation and tell me its usage. Alright, and I will see you in class.